Welcome back to my new Pythia tutorial. Last time I showed you the basics, how you can create your first script with the event loop inside. And when you run through all the events, then you can create a bunch of new particles with the interaction of two protons. And then you can loop over all these particles and give out some information like, for example, the momentum, the mass, the energy and whatsoever. So now we go one step further. And in this tutorial, I want to show you now how you can actually make some statistics with Pythia. So I will show you now how to create histograms that you can show inside the terminal, which is of course not so beneficial, or which you can, for example, convert to Python file, and then you can create a PDF from that. And I think this looks quite good, and you can do some further analysis statistics with that. Okay, so I guess we should start now. Before I do that, I would like to do one more thing, and this is the creation of a Makefile. And the reason for that is because currently we always have to write this long command here. If I take it from last time, G++, and then the input, the header file, the libraries, and so on. And it would be good to have this once and for all in a Makefile, so we only have to type make, and then it will automatically compile the scripts. And this we will do now. So for that, I would like to create a new file, which we call Makefile, and this we can just edit in our text editor, which we like. And normally a Makefile always starts with all double dot. However, we don't want to do that because we want to compile tutorials specifically. So in the future we will have tutorial1.cc, tutorial2.cc, and so on. And we want to choose then with the Makefile which of them we want to compile. So what we will write now here is tutorial %, which is a kind of internal wildcard of make, and then double dot tutorial %.cc. And then that is very important that we have to make a tab here. So if your text editor says that we have spaces, then you have to remove that, and you have to be sure that there is really a tab. Otherwise it will give an error message. So now we make a tab. And then we copy basically our line that we have last time used, G++ and so on, here into our text editor. And the only thing which we have to change now is the name tutorial1.cc to $@. And this $@ is a placeholder, and then it basically substitutes this with the tutorial with number that we are giving here. So now for the output the same. So what we have to write here is also $and @. Maybe one day I will make another tutorial series about how to create Makefiles, but I hope for the time being you can just accept it as it is. So now when we type in, for example, make tutorial1, then it says tutorial1 already exists. Sorry that it's in German at the moment here. Tutorial1 exists already, and this is correct because we created that last time, the binary, so we can delete that. And when we say now make tutorial1, then it compiles, and at the end we get our executable. And of course we have to make sure that when we run this, we have to use the same command that I explained last time to add the library file to our Linux system. And when we did this, then we can just try it one time whether it works. So we can write tutorial1, and as you can see, everything runs smoothly. Okay, so this is basically done, and now we can think about how to do our statistics. And for that, we make a copy of the file tutorial1.cc that we created last time, and create a new one which we call tutorial2.cc. And I think this is quite good because then we can change something there without destroying the code that we have written last time. Okay, so now basically what I want to do now is just create a simple histogram. Let's suppose we want to make a histogram of our of the z component of the momentum of the created particle. So a PZ distribution basically. And this we can do very easily because Pythia 8 already includes some of these functionality, and there is actually a class called hist. So we have to go to our Pythia 8 namespace and write Pythia 8 ... exactly how we have done it here, and then write hist. And then we have to give the name of the object that we want to create, for example HPZ, so the histogram of the Z component of the momentum. We could also plot, for example, the absolute momentum, but we want to have a quite symmetric distribution. So I think PZ is a good value. Then we have to write here the name of our distribution or the name of the histogram. So let's call it maybe momentum distribution. Then we have to define the number of bins. So let's suppose 100. Then we can set the lower limit of our histogram. So it should be maybe 10. I checked already, this is a good value. And the upper value can be, the lower value will be -10 and the upper value will be 10. And then this is in principle everything which we have to do. The only further thing is that, of course, we have to fill our histogram. So we have to write here hpz fill.pz. So now we fill in our histogram the z component of the momentum of all particles that are created. And then in order to show this in our terminal, we only have to add one more line completely at the end behind our event loop, and this would be std cout hpz and then std end line. This is not necessary according to my knowledge, but it's better to write it, I think, to make sure that it really shows everything which is included and flushes the terminal. So now we can write basically make tutorial 2. So now you can see why we created our Makefile, and there is an error message because I think I forgot the semicolon here. Okay, now again we write it, make tutorial 2. And now we get our executable, and this we will start now, tutorial 2. And like last time, it will just produce a lot of output. So first it goes through all the cross sections. And then the actual calculation with 10 events is quite fast. So we can see now here our histogram, but of course the terminal is a little bit too small. So we enlarge it, and now you can see very nicely our PZ distribution. Yeah? Then what it shows here basically is here the number of entries. The title is, by the way, written here. So here are the number of entries, and we know that the lower edge is defined as -10. The high edge, the upper edge is +10, and we have defined 100 bins. So you could identify now from the exact position here, for example, the mean value. However, this is done already by Pythia. So the statistics is shown here below. We have 2035 entries, which means 2035 particles that are created. We have an integral, I guess this is the integral as far as I know, which is a little bit smaller than the number of entries because we have a few underflow and overflow values. So some of the values are basically outside of our histogram, they are not shown. So this is the reason why the integral between these two limits is a little bit smaller. And then the nice thing, it also gives you the mean value, and this should be around 0. And of course, with the limited amount of statistics which we have, this is in principle 0, you can say. And then the RMS value should of course not be 0. This has a value now of 3.4. And I guess when you do some studies about it, then you come to the conclusion that this is the correct value. However, I'm not so much familiar with hadron physics simulation, so I hope that somebody maybe can confirm that. However, showing these values in a terminal is of course nice, but we also want to have some graphics output. I guess this is something which is really necessary if you want to understand plots, if you want to make fits, if you want to include this in your thesis or in the publication, for example. So for that purpose, we can basically use a built-in function again of Pythia, and this is called a histplot in the namespace of Pythia 8. As usual. So we have to write here Pythia 8 ... histplot. And then the name of our object. So we call it maybe HPL for histogram plot. And then in the constructor, we have to give the name of our Python file that we want to create. And this should be maybe tutorial 2, just for convenience. And then one thing we have to add in any case to that histplot. This is the outer frame basically. So we have to write HPL frame, and then the first argument of our constructor is the name of the PDF file that we want to create after running our Python script. So we maybe just call it output. So later the name will be output.pdf. And then we have to give the name of our histogram. Again, we call it maybe momentum distribution, then we have to give the name of our x-axis, the label of our x-axis, which is maybe momentum, and then we have to give the name or the label of our y-axis, and this should be maybe entries. And then we have to only add our histogram that we created here, which is called HPZ. And at the end, the last step which we have to do is writing HPL plot. And when all this is correct, and now we will test that basically. Sorry, I didn't save it. Now we will run it again. Yeah, it works. So when we now run our program, it should create a Python file, and then we can run this Python file in order to create a PDF. So let's run it. And this will again take the same amount of time. Okay, it's done. So now we can take a look at what files are created, and you can see two files which are new, and one is output0.dat and one is tutorial2.py. So we can just take a look maybe at the output0.dat just to see what is inside. And these are just basically the values which we later want to plot in our histogram. So we have 100 lines because we have 100 bins. So I think everything is absolutely perfect. And now we can have a look at our tutorial2.python file. And as you can see, it uses matplotlib for plotting, and from that PyPlot. So I hope that you are familiar with that. If not, you can check the PyPlot tutorial on my channel, where I'm explaining all the basics. So when you have done that tutorial, then you will understand all the lines very easily. So what it basically does is creating the output.pdf file. Then it defines some parameters like the size of our plot, for example. Then the input file, this output0.dat. Yeah, and here it sets, for example, the x limit and the y limit, and some labeling and the title, y label, x label that we have defined before. And at the end, when everything is plotted, it basically creates this PDF, stores everything, and then closes the PDF. And as I said, just have a look at my PyPlot tutorial if you want to go more into detail. And now in the final stage, we can just write Python 3 for plotting it, Python 3 and then tutorial2.py, and this is fast. So now it creates another PDF file here inside, which we can basically open by just writing evince output.pdf. Of course, you can also use any other PDF viewer what you have on your system, output.pdf. And when you have a look at this, then very nicely you can see here the momentum distribution. So what we have seen before in the terminal, we can see now in the PDF form. However, the statistics is very low. I don't know what kind of distribution we expect. Maybe it's not a Gaussian, but at the end, when you know this, you can maybe make a fit to that, but you can also export it directly, or you have the PDF already, which you can directly insert in your thesis or in your presentation or publication, and yeah, impress people with this. So I guess this is everything which I want to show today. I hope that you enjoyed it and you like the content, and that it helps some of you who asked especially questions in the comment sections. If you have any further ideas or comments what I should explain, please don't hesitate to mention that. I will be happy to take care of that. And yeah, if you like the video, then please hit the like button, subscribe the channel if you have not done so far, and I will be happy if you stay tuned until my next video will come out very soon. See you.